In this video, I'll give you 4 strategies for simplifying trig expressions, and then just talk through a couple examples. Really, the key to being successful in this section is just kind of noticing key characteristics, and I'll try to just go through some examples and point those out for you. Really pay attention more to kind of how I'm thinking about it rather than the actual steps I'm taking, because the steps are going to be different for every problem, but the thinking will be similar for all problems. So one key strategy that you're going to end up using is rewriting everything in terms of sine and cosine. So we'll look at a couple examples of that. What I mean by that, obviously if I have secant of x, that's 1 over cosine. We maybe haven't used this quite as much, but tangent we can think of, we've thought about it a lot as y over x, but we can also think of my y value on a unit circle as being the sine and the x value being cosine. We did that in an earlier video. So tangent is really sine over cosine. And all of these are listed up here at the top here. Okay, and so when I say rewrite in terms of sine and cosine, this is really what I'm talking about. You could see cotangent we can think of as x over y. And on the unit circle, that's going to be cosine over sine. Even if it's not on the unit circle, the radiuses cancel out. Don't stress about that. But we can use these to our advantage, and we will. So that's one strategy, sine and cosine. Another is rewrite using the Pythagorean identities. That's going to be useful as well, and we talked about those in a previous video. Using factoring is going to be a strategy, and then just really 3 and 4 are kind of similar here. Rewriting, sometimes that's just getting common denominators and putting together, or else splitting a fraction into multiple fractions, kind of reverse breaking it apart, really. And so let's go ahead and take a look at the first example here. We've got sine squared x times cosine squared x plus cosine to the 4th x. And a little note, I mentioned this earlier, but this really means to take something to the 2nd power, take it times itself. So I'm looking at these strategies. We're already in sines and cosines. Rewrite using Pythagorean identity. That might be useful, but I'm seeing something else going on here. So we do have the key Pythagorean identity, sine squared x plus cosine squared x equals 1. And if I did have this in here, or some form of it, I would probably jump right to it. But here I have times, and so that's not going to work here. If it was a plus here, I would definitely change that to a 1. So I'm looking at it, and I'm seeing some common terms. I'm thinking factoring might come into play here. So I don't know if it helps you to think about it this way. If having the trig functions is too much, I would encourage you just off to the side to think about it like, okay, let sine equal x, let cosine equal y. So then this kind of becomes x squared times y squared plus y to the 4th. And then you can see, hey, I can factor out a y squared here. Look familiar, huh? That's really what we're going to do. We're going to factor out a cosine squared here. So they'll take out a cosine squared. We're then left with sine squared x plus, well, if I had 4 and take out 2, now I have cosine squared x left. And hopefully you're thinking, aha! Now, you might not be thinking that quite yet, but I am, because we know that's equal to 1, and that greatly simplifies things. So cosine squared x times 1, which is just cosine squared x. And this is much simpler than this. And that's the key, is to simplify these expressions down. So key point here is just recognizing common factors and factoring that out and seeing what happens when I'm done. When it really simplifies down, you know you're on the right track. Number 2, cotangent theta over cosecant theta. We need to figure out how to simplify this. I'm looking here. Pythagorean identities are out because I don't have any squared terms, at least not yet. Maybe if they pop up. Factoring again is probably out, and rewriting is out. That leaves us in terms of sine and cosine. If you look further up, you'll see cotangent theta is cosine over sine. And we know cosecant is the reciprocal of sine. And so we just rewrite those cotangent as cosine theta over sine theta. All of that divided by cosecant, or 1 over sine theta. Now, I don't know the best way to go from here as far as what will resonate with you. I learned to deal with this by thinking about it this way. This is really a division symbol. And once I have a division symbol, then I change it to multiplying by the reciprocal. And then from there, I just get cosine theta divided by 1, which is just cosine theta. Now, some of you, that won't resonate with you at all. Instead, you can just think about multiplying. You see the sign in the bottoms here? So if I multiply the numerator by sine theta over 1 and the denominator by sine theta over 1, as long as I multiply the top and the bottom by the same thing, I can do this. And now you see that these cancel. And I have cosine theta divided by 1, which just gives me cosine theta. And in the denominator, I just have a bunch of 1s. 1 divided by 1, which is 1. So that is equal to cosine theta. Either way, it works. I don't know which one you like better. Maybe comment in the video. Do you like this better? Multiplying by sine over sine? Or do you like to divide first and then multiply by the reciprocal? And that is 2 strategies